Hello friends, welcome to UGC EPG Pathshala. I am Atika Tajdar from Department of Geography, Jamia Millia Islamia. Today we are going to discuss on disaster management for earthquake. First of all, we will try to understand the basic concept of earthquakes and associated hazards and also explore the possibilities of managing earthquake hazards, mitigation, preparedness, response and recovery to earthquake hazard and associated secondary impacts. Earthquake is a geophysical phenomenon which is considered as the interplay of geological and geomorphological dynamism of Earth. The Earth as a whole is composed of three main layers: the crust, the mantle and the core. According to the plate tectonic theory, the crust, which is the outermost layer of the Earth, is made up of the lithospheric plate that float over the viscous mantle layer and remain in isostasy. The plate forming the crust move away, towards or past each other very slowly over the mantle. When friction or interaction between two plates occur, it results in the sudden release of energy in the form of waves that move along the earth crust and is termed as seismic activity or earthquake. The boundary between two plates is generally encountered with faults or other structural deformities. Faults are not continuous but usually consist of a fault zone or discontinuity that is present due to the rock mass movement. During an earthquake, the movement of rock block along the line of weakness give rise to seismic waves spreading outward along the surface of the earth in all directions simultaneously. These waves are grouped into two main types. First is the body waves consisting of P waves and S waves. The former moves in solid and liquid medium and are having greatest velocity. Similar to sound waves, S waves travel slower than P waves and are more destructive than P wave, though it cannot travel through water. Surface wave consists of Rayleigh and Love waves. In Rayleigh or ground roll, the surface moves vertically and horizontally, leading to vehicles and stationary objects moving up and down. They are slower than S waves. Love waves move ground from side to side, resulting in horizontal ground motion. Measuring earthquake. Based on the differences in velocity and motion of the waves, instruments like seismograph and accelerometer could be used to measure earthquake. These instruments measure the resultant displacement, velocity and acceleration of the ground movement arising out of the seismic waves. By measuring these waves, the center of release of energy and its distance from the location of the instrument can be found. This center of release of the energy in the interior of the earth is the focus or hypocenter, and the corresponding point on the earth's surface lying perpendicular to the focus is epicenter. The magnitude of the earthquake is the relative size of the earthquake and is arrived based on the maximum motion recorded by the seismograph. The size of the earthquake is measured using the moment magnitude scale. The scale is derived by modeling earthquake recordings from different recording stations. Magnitude are represented on the logarithmic scale with base 10, thereby a difference between a magnitude 4 and a magnitude 5 is about 10 times more ground shaking and about 32 times the energy released. The impact or effect of the earthquake of a particular magnitude on the earth's surface is the intensity of the earthquake. It is measured using a scale consisting of increasing levels of intensity from not felt to damaging buildings and structures. Modified Mercalli intensity is predominantly used scale. The relation between the magnitude and the intensity varies. 0.0 moment magnitude earthquake in a desert region would have limited intensity, whereas even a 6.5 moment magnitude shallow earthquake near an urban center would have higher intensity due to the absence of settlement in the desert. ISO or seismal lines are imaginary lines joining places that experience same earthquake intensity. Co-seismal are imaginary line joining places that experience the earthquake at the same time. They are plotted for each earthquake. On the basis of such line and data collected over the years, a statistically backed deterministic model are developed estimating future earthquake to help in better preparedness and risk reduction measure. Due to unavailability of decade or century-old data as required, deterministic models are difficult to arrive at. Thus, a more realistic approach is the prediction of earthquake with the probability associated with it. It is known as It is known as earthquake forecasting. This forecasting is done by seismic hazard analysis by estimating the probability of ground motion exceeding a certain value at a certain location. These hazard analyses help in estimating future earthquake and thereby in the generation of seismic hazard map and other predictive models. The complexity with seismic risk do not only stop with earthquakes. The different cascading hazard arising from earthquake are as follows. The observed unhygienic condition prevalent in the urban poor areas due to lack of basic facility like sanitation and sewerages and unplanned construction led to secondary health issue post-earthquake disaster. Fire is another associated secondary hazard. Unplanned and dense construction impedes fire fighting also, especially when most of the local capacity for response focus on urban search and rescue, and when enough space is not available between buildings for the firefighting equipment to reach the fire-affected areas. Earthquake also pose significant threat to lifeline or critical infrastructure like roads, power supply lines and power stations, water supplies, sewage lines, bridges, schools, hospitals, etc. Strengthening of critical infrastructure and immediate revival of supply to ensure relief to chronic patients, disaster-affected injuries and casualties. Earthquake in ocean or seas could also trigger tsunamis or giant waves. The Indian Ocean tsunami on December 26, 2004 occurred due to an earthquake of magnitude 9.1 movement magnitude near Sumatra Islands. It brought about giant wave in the Indian Ocean that affected 14 countries, killed more than 2 lakh people and displaced thousands more. Earthquake in mountainous areas bring about landslides or rockfalls. Earthquakes generate a large number of induced landslides in close proximity to the epicenter region. Planet team of the epicenter region of the Geoziago earthquake dated 9th August 2017 showing the landslide induced due to earthquake. Earthquake preparedness and mitigation measures must therefore not only consider the ground shaking but must also incorporate mitigation measure and response to multiple cascading hazard associated with it. Earthquake and risk management. Earthquake bring about great distress to individual and communities. An analysis of the CRED data from 2000 to 2016 reveals India as the 4th highest number of deaths due to ground motion at 2,393 per earthquake. Average death per earthquake due to ground shaking analysis of CRED data. Considering the devastating impacts of earthquake not only due to the high number of casualties but also due to associated destruction to property, several measures have been undertaken to minimize the impact of earthquake and develop earthquake resilient structures. It is significant to note that the event of earthquake as a ground motion doesn't create destruction. It is their effect on building that causes the collapse of building or building components that impact the occupants of the building. Now, let us understand the effort to recognize and minimize earthquake risk. Earthquake zonation. Seismic hazard maps help in classification of areas according to observed and predictive past seismicity. India is divided into 4 zones, Zone 2nd to Zone 5th, with respect to the observed and probable seismicity according to IS 1893-2002. No location in India exists in Zone 1, as no location in the country is considered completely free from seismic hazard. IS 10893-2002 is the Indian standard pertaining the microzonation of seismic hazard. It has been modified on the least 5 occasions, with the major one post Latur 1993 and Bhuj, which is in 2001 earthquake. Microzonation thus at a national level is not sufficient to assess and prepare for seismic hazard. Tremors were felt in Delhi in correspondence with earthquake as far away as Nepal or Afghanistan. Thus, the changes observed in intensity of earthquake due to changes in geological and geomorphological configuration within the microzones led to the requirement of microzonation for seismic hazard. Microzonation involved the incorporation of seismological, geotechnical and geologic consideration along with the land use planning for estimating earthquake effect on the area under consideration. It is thereby aid in site or design consideration in order to be less susceptible to earthquake damages. Better equipment, motion station, and advent in interpretive sciences and probabilistic and deterministic assessments led to a better understanding of seismic hazard in map of a smaller scale. While macro zonation gives an indication about the most credible earthquake in the particular area and the probability of its occurrence, microzonation helps in identifying area with a district or a metropolitan city that could be more susceptible or damages, for example due to liquefaction potential of the soil, or the construction practice in the place area being unsuitable to the most credible earthquake probability. Construction code: any building must consider the following forces: wind, dead load, which is the weight of the building components; live load, the variable weight due to the occupancy like people, furniture, machinery, etc., and earthquake load. The building must stand stiff under normal condition by taking into consideration the first three loads, while during ground shaking associated with earthquake, the building must be ductile enough to dissipate input energy and not collapse completely. The extent to which the building must be ductile would depend on the location of the building and the geological constituents of the ground in these locations. Wind and earthquake load is the only during the occurrence of extreme wind condition or during ground motion, whereas the design of the building taking into consideration the dead load and live load is completely under the control of the building designers and construction workers. The fact that a building is not tested for its durability or for its capacity to withstand wind or earthquake load, unlike automobiles or other products sold in market post obtaining fitness certificates from concerned authorities. For building, the occupation certificate, which is also called OC, issued by the local administration, certifies the compliance of the buildings to the local health and safety requirements. Occupation certificate is issued on the basis of the construction code in place. These are developed to identify suitable building construction material and method for earthquake resilience of building based on the seismic hazard map and the micro and macro zonation. There are instances of traditional ways of building houses and commercial structure that have an understanding of the local geological and geomorphological consideration, and thereby developing an understanding about the geotechnical concept to utilize appropriate construction material in an appropriate manner, so that the building built do not collapse and cause damage to property or lives during earthquake. The Koti Banal architecture of Uttarakhand is one such example. In India, the Bureau of Indian Standards, which is also called BIS, developed construction code that act as mandates for safe seismic resistant construction, ensuring the buildings may stand firmly despite seismic activity. The ISO, seismal and corresponding peak ground and peak ground acceleration are considered in building codes. Thus, it serves as a bridge between the earth system and the built environment consisting of the building and habitat built by humans. National Building Code. The National Building Code of India, which is also called NBC, is a comprehensive building code that provides guidance for regulating construction activity across the country. It serves as a model code by agencies involved in building and construction activity, including the Public Work Department, local bodies, or private construction agencies. The code certain regulation, development control rules, building requirement, stipulations regarding material, fire safety requirement, structural design and construction, including safety, building and plumbing services, approaches to sustainability and facility management. The list of standards pertaining to earthquake as per as the BIS are tabulated in the table. Role of Reconnaissance mission in updating building codes. Post-earthquake, Reconnaissance mission have been undertaken by formal institutions to gather the extent and reason of losses post-devastating earthquakes. The Reconnaissance mission played a very important role in learning from past failures. The impact studies undertaken post the Great Kanto earthquake in Japan in 1923 and Great Nobi earthquake in 1891 were among the first recorded post-disaster missions that led to introduction of the mandatory requirement of all buildings to incorporate a seismic coefficient of 0.1 as per the urban building law. Nicholas Embraces summarizes the scope of Reconnaissance mission post-earthquake like it is increasingly apparent that the site of damaging earthquake is undoubtedly a full-scale laboratory in which significant discovery can be made by keen observers, seismologists, geologists, engineers, sociologists and economists. Present, there are 6 recognized formal scientific institutions across the globe that are primarily dealing with post-earthquake reconnaissance mission. EERI, Earthquake Engineering Research Institute. Second is EEFIT, the Earthquake Engineering Field Team. Third is GTF, German Task Force. Fourth is UNESCO Task Force. Fifth is AFPS, French Association for Earthquake Engineering. And the sixth is JSCE, Japan Society of Civil Engineering. Building Code and Informal Construction. Establishment of Model Building Code and bylaws is the key step towards seismic risk mitigation. A major part of the success of building code is in its implementation. Generally, housing is segregated into formal and informal categories. An accepted understanding of informality in construction practice is that informal construction does not recognize or regard the local rules and laws in place in its design and construction. The informal construction includes slum construction in urban localities that are considered most vulnerable during earthquake. Given that the slum areas are generally situated in the floodplain or in the areas that are repeatedly affected by multiple hazards. Floodplains are usually made of loose soil and the liquefaction potential of loose soil is generally higher than the adjoining soil. Further, the dense concentration of building also impede in evacuation or urban search and rescue. Now, let us understand what are the institutional framework for seismic risk management in India. The National Disaster Management Plan 2016 or National Disaster Management Authority Government of India 2016 lays down the important step and recommendation for the seismic risk assessment and disaster preparedness. The plan has entrusted India Meteorological Department to monitor earthquake and form a real-time seismic monitoring network and disseminate information to agencies involved in earthquake tracking, research, mitigation and response. Geological Survey of India, in coordination with India's Meteorological Department, is responsible for hazard zonation and micro-seismic zonation of vulnerable areas. The National Disaster Management Authority, National Institute of Disaster Management and other science and technology department and institutions have been entrusted with the task of earthquake hazard risk and vulnerability assessment. The BMTPC, which is Building Material and Technology Promotion Council, in coordination with the Bureau of Indian Standard, which is BIS, and other institutions formulate and update the National Building Code and other standards. The State Department are required to act accordingly and ensure measures to understand and mitigate seismic risk. The Ministry of Home Affairs, Government of India, is identified as the nodal agency for coordinating earthquake response and central assistance, while the State Disaster Management Authority, Revenue Department and Commissioner for Relief, along with the panchayats and urban level bodies, are responsible for the organization of immediate response and to seek further assistance if necessary from central agencies. A special housing scheme, retrofitment of prioritized lifeline structure. A special housing scheme, retrofitment of prioritized lifeline structures and building and hazard resistant construction, model code for town planning, civil and public work and conduction of safety audits have been given due importance, and the Ministry of Rural Development, Ministry of Urban Development along with other relevant ministries are responsible to devise strategies and plan in the regard. Development along with other relevant ministries are responsible to devise strategies and plan in this regard. The implementation and compliance activity are the responsibilities of State Department. Capacity development for earthquake-related trainings, curriculum development have been tagged to NIDM, NDMA, Ministry of Earth Sciences, Ministry of Human Resources and Development, University Grant Commission and other institutions. Awareness generation plays a key role in the earthquake preparedness, and NDMP has identified NDMA, NIDM, Central Armed Police Forces and National Disaster Response Force, which is NDRF, as the central agency in charge of carrying out mass media campaign promoting the culture of earthquake risk prevention, mitigation and management, promoting attitude and behavioral changes in the awareness campaigns, the promotion of risk transfer and insurance, community radio and the strengthening of civil society organization. All state departments, including state disaster response forces and fire and emergency services, civil defense, police, DDMA and panchayat are to assist and enhance the awareness campaign and promotion of culture of earthquake risk consciousness in the public. Mock drills are also to be conducted by the central and state agencies regularly. Earthquake preparedness and response. The first priority in earthquake response is to minimize loss of life by undertaking effective search and rescue operation and the evacuation of affected people. Evacuation is categorized as preventive before materialization of hazard. Evacuation is characterized as preventive or post early warning before materialization of hazard, protective or as a precaution, rescue oriented falls under search and rescue and reconstructive resettlement in safe location. Search and rescue, which is also called SAR, is the technical activity undertaken by trained personnel who rescue and attain the casualties under adverse condition. A specific response during earthquake hazard include rescuing victim from rubble, special care in case of fire, evacuation of at-risk people in safe location, rendering first aid and positioning of ambulances. Earthquake recovery. The planning for earthquake recovery ideally begin immediately after the earthquake event. Decision regarding institutional mechanism for managing rehabilitation and reconstruction activities, allocation of financial resources, identifying and prioritizing reconstruction activities with a robust monitoring and evaluation and community information and communication program are essential in the post-earthquake recovery framework. The framework should be based on thorough analysis of reliable data pertaining to disaster impact and the post-disaster recovery needs. Alignment of disaster recovery with the National Development Goal, aid in better sustainability, and the mainstreaming of disaster risk reduction effort into development agenda. Key components of post-earthquake recovery include the managing post-disaster funds, monitoring and management of recovery process, transitional shelter programs, environmental and social assessment, decision pertaining to the relocation or rebuilding, debris management, focus on vulnerable segments such as women, children, elderly, differently abled, etc., proper seismic assessment, decision pertaining to land tenure or regularization of slums, income support or livelihood recovery programs. Now, let us summarize the lesson we have discussed. Earthquake is a geophysical phenomenon. Seismic activity or earthquake is a sudden release of energy in the form of waves that move along the earth crust. It causes the collapse of improperly designed constructed building or building component that cause impact on the occupant of building and bring about great devastation. Establishment of model building code and bylaws is the key step towards seismic risk mitigation. The National Disaster Management Plan 2016, the Disaster Management Authority, Government of India 2016 lays the plan of seismic risk assessment and addressal. Earthquake preparedness and mitigation measure must not only consider the ground shaking but must also incorporate mitigation measure and response to multiple cascading hazards associated with earthquake like landslide, fire and damage to critical infrastructure. Thank you.